Now get down to work. Hi, everybody. All right. So, whoops. There we go. So there's this lantern here, okay? And there's quadrilaterals basically on each side. A, B, C, D. Quadrilateral. How can we easily, what's the most easiest probably way to tell that that's a parallelogram? How could we most easily tell it's a parallelogram? Micah. Yeah. Get out a tape measure. See if this side is congruent to this side and this side is congruent to this side. That's how I do it. Just measure. Now, once we figure out, hey, that's a parallelogram, how do I figure out if it's a rectangle or not? Not the 90 degrees, because it's not like you're going to have a protractor on you to measure the 90-degree angles. You have a tape measure, and what would you do with that tape measure, Tatum? Yeah. If you notice, if you measure the diagonals and see that CA is equal to BD, then yep, that's a rectangle. Now, if you have ever been around construction or work construction, concrete construction, or building houses or building any type of building, you always measure the diagonals of your base, okay? Because you want to start with a rectangle. If it's just a parallelogram, because I mean, I'm going to build a shed that's 8 by 10 and make this 8, this 10, this 8, and this 10, you think, oh, okay, I got a rectangle. But the problem is, and no, nobody would like build it this off, but let's say it's a little off like this. What happens then is your walls don't line up, and then your roof line doesn't line up, and you can't build a very good shed, very solid shed. That's why you need a rectangle, and that's why all carpenters measure diagonals when they set up, on a little job. The bigger the job, then they have to like measure out 10 or 8 feet, measure out 6 feet, and then make marks, and then measure those marks to see if they're 10 feet apart to make sure they have right angles on the corners using Pythagorean theorem. Lots of geometry used in building. Okay, can we say this is a type of, this is a parallelogram. What type of a parallelogram is it? Is it a rectangle, rhombus, or square? Why is it a rhombus? Because its diagonals are perpendicular. When the diagonals are perpendicular, it makes a rhombus. Okay? So, if the diagonals of a parallelogram are perpendicular, then that parallelogram is a rhombus. If the diagonals of a parallelogram bisect opposite angles, then that parallelogram is a rhombus. If the diagonal splits these two angles congruently, then it's a rhombus. Perpendicular means cut it at a 90-degree angle. Okay, so here's an example of what I'm talking about with construction. Ashton measures diagonals for his deck and finds that they are congruent. Will the deck be rectangular? Yes. As long as the diagonals are congruent, you have formed a rectangle, as long as the opposite sides are congruent as well. Yes. So it's had a bad day.
It's still good.
All right. So this says, whoa. Ugh. Boom. I don't think so, no. All right. This says if the diagonals are congruent, then it's a rectangle. All right. Is this a square, a rectangle, or a rhombus? With rhombus, because you're told that it's a parallelogram. And when you know it's a parallelogram, opposite sides are congruent. So this makes this, and this makes this. So all 4 sides are congruent. And this diagonal is bisected, but it doesn't say anything about this. So you're going to say that it's a rhombus. If it had right angle, one right angle, then what would it be? Not just a rectangle, but a square. You want to be the most accurate as possible. Yes. All right. What is this?
It can't be a square or rectangle because Gilly, what is it? It doesn't have 90 degrees. None of the above.
Okay, here. What I will say about this one, and Illy will complain, but that's just fine if Illy complains. The drawing may not be drawn accurately. The drawing may not be drawn accurately, but looking at the information given, what is it? It is a square. And you're going, what? Well, opposite sides are congruent, which all of a sudden, all four sides are congruent. Hey, quit chattering. And then what this is, diagonals bisect each other in a parallelogram. So this is equal to this, and this is equal to this, and all of a sudden, well, this whole thing from here to here should be equal to this whole thing from here to here, which makes it a rectangle and a rhombus. So to be the most accurate, it is a square.
Okay, but so there was congruent lines on the other side, but you didn't say that the other one was congruent.
But we were told it was a parallelogram. So in a parallelogram, diagonals bisect each other. So what's ever on this side has to also be on this side. And what's on this side has to be on this side. Okay, so since these are the same, then the diagonals are congruent, which makes it a rectangle, which makes it a square. All right. Now, to make this a rhombus, what would x have to be? Set them equal to each other. So 4x plus 3 equals 5x minus 10. So subtract 4x. So 3 equals x minus 10. Add 10. X equals 13. What would y have to be? So, nope, not that. If we add y, 65 equals 6y plus 5. Subtract 5. Subtract, not add 5. 60 equals 6y. Y equals 10. What are the values of x and y? 13 and 10. This one, what would you do with 1 and 2? Set them equal to each other. 3 and 4, set them equal to each other. I think we can do that. Okay. Kickball field. The bases are all 60 feet apart. How do we make it a square? How do you know?
Because it looks like one. Check the diagonals.
You have to check the diagonals. If you measure from first to third, and from, doesn't have to be 90 feet, no. And it,
a little bit not straight.
yeah.
Looks like a jellyfish.
Because I'm trying to draw a straight line. So if you measure from home to second and from first to third, they should be equal. And if they are, then it's a square. All right. So what makes a rhombus a rhombus? If you start with a parallelogram, if the diagonals are perpendicular, if they bisect opposite angles, that's a rhombus. What makes a parallelogram a rectangle? If the diagonals are congruent. What makes it a square? If the diagonals are both congruent and perpendicular, or congruent and bisect opposite angles. Okay? So I will give you the assignment. At 10:30, a half hour from now, we will start reviewing. So some of you didn't finish last time's assignment. so you can finish last time's assignment as well.
And then if we get done, we can set up the Christmas tree.
Yeah, I gotta find a table for it.
That table, remember? You said you were gonna put
Well,
it in the
no,
corner.
because some people use that because they have to plug in their computers. I'm sorry. I'm gonna go figure it out.
Well, you should
Trust me,
figure it out
Ainsley.
quicker.
Cambry.
What about this one? What about this one?
I was thinking about this one possibly. We'll see. Because we can put away the calc books and pre-calc books now.
Yeah, they've been sitting here all day.
No, they're there. So then they're there, so the kids can grab them during class and then put them back. What?
You should delete that because I did it on paper, but it says it's like.
I know I can delete it. It won't let me.
Hey, it'll go away after like 3 months.
Yeah, but it still says it's missing.
I know. But let me put out the assignment because you guys are distracting me.